Welcome to The Explainer. Today, we're diving into a really fascinating white paper from Day 4 of Google's AI Agents course, all about securing these incredible systems. But before we get into the tech, I want you to just picture a scenario for a second. Imagine you've got a brand new employee walking into your office on day 1. They haven't even had their morning coffee, they barely know where the restrooms are, and you sit them down at a desk.
And suddenly they're looking at a screen that says, "Full system access granted." You've literally just handed that completely naive new hire the master passwords to your company bank account, your private customer database, the whole shebang. Sounds absolutely terrifying, doesn't it? It's a recipe for instant disaster. But the crazy part is, this is exactly what so many people are blindly rushing to do with artificial intelligence right now. They just want to plug an AI agent into their business and let it run completely free.
And that really brings us to the most critical question in modern software engineering. Can we trust it? As we unpack this Day 4 material, we absolutely have to pause and ask ourselves this fundamental question. Look, AI is undeniably powerful, but if we're going to hand over the keys to our digital kingdoms, trust isn't just a nice to have, it's the entire foundation of the system.
Which leads us to our first major concept, the need for breaks.
AI is breathtakingly fast. It can write thousands of lines of code in seconds, build entire applications, and process data at lightning speeds. But think about a speeding sports car. Putting a massive, ridiculously powerful engine in a car is actually incredibly dangerous if you don't also install high-performance brakes and seatbelts. In that exact same way, an AI generation engine is entirely useless and honestly potentially deadly to your business without a robust set of safety controls wrapped around it. We call this safety layer an AI harness.
So let's explore how we actually build a layered security architecture. To really understand these safety controls, let's shift away from abstract code for a minute and just think about protecting a physical house. You'd take a step-by-step approach, right? First, you put up a perimeter fence, then a secure gate. Third, you'd probably install a warning alarm, and finally, you have your internal locks. Modern AI systems are protected using this exact same philosophy. We rely on multiple, overlapping layers of digital defense. If one layer fails, another one is right there to catch the issue.
One of the absolute most important layers is called sandboxing. Think of a sandbox like a secure, fenced-in digital playground. Inside this sandbox, the AI can build, it can experiment, and most importantly, it can break things and fail completely safely. Because it's so heavily restricted, even if the AI writes a catastrophic piece of code, it cannot affect any outside systems. It remains completely isolated.
Another critical layer is permissions. Just like human employees, not every AI agent needs the master keys to the entire company. Take a marketing agent, for example. It definitely needs access to marketing dashboards, but it should be strictly blocked from the payroll system. Conversely, your finance agent needs access to payment systems, but has absolutely zero business looking at marketing data. By strictly limiting what each AI can see and do, we drastically reduce the blast radius if it happens to go off track.
Now for testing the defenses. Because once we've built all these digital fences, how do we actually know if they work?
Well, behind the scenes of these major AI models, there is a constant simulated cyber warfare going on, split among 3 distinct teams. First, the red team. They act as the attackers, deliberately trying to break into the systems. Then you have the blue team. They're the defenders, tasked with constantly patching and fixing the vulnerabilities the red team exposes. And finally, the green team focuses on building stronger, structural defenses safely over time. It's this continuous, completely fascinating loop of attack, defend, and improve.
Which brings us to evaluating true value, because we have to look beyond just security.
You see, security really only tells us if the house was broken into, but evaluation tells us if the AI actually created any value in the first place. And that brings us to the ultimate test, intent satisfaction. Testing a simple math problem is super easy. 2 plus 2 is 4. But evaluating a complex AI application isn't about rigid right or wrong answers. It's entirely about user fulfillment. Intent satisfaction asks one thing: did the user actually get the exact result they wanted? The AI might have generated something incredibly technical, but if it didn't satisfy the user's intent, it failed.
Think about it like this. You could have a technically flawless app. The code compiles beautifully, the servers are humming along, it's completely bug-free. But if it ignores the user's specific requirements, it's a terrible outcome. What actually matters is delivering exactly what the user asked for, like successfully delivering a specific dashboard. In the world of AI evaluation, fulfilling the specific customer request is really the only outcome that actually counts.
So how do we measure that success? Let's talk about session convergence.
The reality of working with AI is that success is rarely achieved in a single magical prompt. Instead, we measure it through a conversation timeline, hoping for what we call fast convergence. Let's say turn 1 is the initial user request. The AI takes a swing at it, but maybe it's just a little off. In turn 2, the user issues a correction. No, actually, make it look like this. By turn 3, the AI has rapidly learned from that correction, hits the target, and boom, success and satisfaction. That fast, 3-step dance is exactly what you want to see.
But there is a dangerous tipping point here, and that number is 10. If an AI requires 10 or more conversational turns to get a request right, turn 1, turn 2, turn 5, turn 8, just constant repeated corrections, that is a massive red flag. That's poor convergence. And what happens when a user has to correct an AI 10 times in a row? They get incredibly frustrated, and they completely abandon the software. Poor convergence literally kills AI applications.
So how in the world do developers fix this? Well, when you have thousands of users, you inevitably get thousands of corrections. Each "no, not like that" is a valuable data point. Modern systems use automated complaint sorting to group these failures together into recognizable patterns: layout issues, design issues, payment issues, navigation issues. This amazing process is called failure clustering, and it automatically reveals the AI's hidden blind spots so human developers can quickly step in and fix them.
And we're even pushing the boundaries of how we evaluate these systems before the user ever sees them. It's called visual evaluation. Cutting-edge AI systems now have the capability to literally look at screenshots of the applications they just built. The AI visually checks the screenshot against the user's original design requirements to ensure it actually looks right. It's essentially evaluating its own visual homework before a human ever has to check it. No way, right? It's pretty mind-blowing.
All of this brings us to a really profound realization from the white paper, and I quote, "The challenge is no longer generating software. The challenge is verifying it." Just take a second to let that sink in. Generating code is quickly becoming the easy part. Building the application is almost trivial for a powerful AI. But connecting the dots between security, testing, and evaluation to ensure that software is actually safe, reliable, and genuinely useful, that is the real mountain we have to climb right now.
Which leaves us with this final provocative thought. Generation is easy. Verification is the new skill. Yes, for sure, AI can build, AI can code, AI can create rapidly. But the people and the businesses who will truly thrive in the future won't just be the ones blindly generating content. They are going to be the architects, the ones who actually know how to evaluate, safely secure, and properly guide these incredibly powerful systems. So the big question is, are you just generating, or are you learning how to verify? Thanks so much for joining me on this explainer, and keep exploring.